I welcome you to another series of our videos. If you haven't subscribed, ensure you do so. So, in this video, we'll be discussing dimension analysis. So, the problem at hand is coming from COA 11th edition, problem 3. Okay, so the question reads, a shape that covers an area A has a uniform height h has a volume given by this equation. So V is equal to AH. V stands for volume, A is the area, then H is the uniform height. So A, they are asking us to show that V is equal to AH is dimensionally correct. Then B, show that the volumes of the cylinder and of a rectangular block can be written in the form of V is equal to AH, identifying A in each case. Note that A, sometimes called footprint of the object, can have any shape, and that the height can, in general, be replaced by the average thickness of the object. So this is just a hint. So let's see how we can do this question. So for the equation to be dimensionally correct, the left hand side and the right hand side need to be equal. If the dimensions of the left hand side and the dimensions of the right hand side need to be equal for the equation to be dimensionally correct. If the dimensions for the left hand side are not equal to the dimensions of the right hand side, then the equation is dimensionally incorrect. So let's try to see this problem or this question we've been given. So this is our equation. V is equal to AH. So like we've said, for the equation to be dimensionally correct, left hand side must equal right hand side. So this is a statement that has been written here. LHS, left hand side, is equal to right hand side. So we are dealing with the dimensions of both sides. So we have V here, which is the volume. We have AH here, A, which is the area, H, which is the height. So let's see. Volume, the dimension for volume is L to the power 3, which we have written here. And these dimensions should be in brackets because this is how we write dimensions. So let's also look at the dimension of area. The dimension of area is equal to L squared, which we have written here. Then what is the dimension of height? The dimension for height is just another form of length. So the dimension for height is L. So we can see that area and height are multiplying here. So what do? We multiply their dimensions. So L squared multiplied by L. What do we get? So when you multiply L squared and L, you get L to the power 3. So at this point we can tell that left hand side, we said it's L to the power 3. Then right hand side after multiplying is L to the power 3. So we can tell that the dimensions on the left hand side is equal to the dimensions on the right hand side. So at this point we can conclude to say the equation V is equal to AH is dimensionally correct. So just to recap, for the equation to be dimensionally correct, the dimensions of the left hand side must equal the dimensions of the right hand side, so which we have written here. So let's look at B. So at B, they want us to find the, let's look at what B. Okay, so B, they want us to show that the volumes of a cylinder and that of a rectangular box can be written in the form of V is equal to AH. So let's see. So the volume of a cylinder. The volume of a cylinder is given by pi r squared h. So pi r squared h, that's the formula for volume of a cylinder. So from the equation we have written here, we can tell that pi r squared is the formula for the area of a circle, because this cylinder has a circular base. So this is the formula. So we can tell that in this equation, pi r squared is representing area. Then height is what we already have in the equation of the equation like this. So we can say that since this pi r squared h is representing area and we already have the height, so we can say that this equation can be written in the form of this. So we have shown. So mainly it's the issue of base area. So let's also look at the volume of a rectangular box. So volume of a rectangular box is given by V is equal to LBH. L representing the length, B representing the breadth or width, then H representing the height. So we can tell that this rectangular box, the base is in rectangular form. So the base area is given by LB. So area is equal to LB. So we can tell that this LB is representing the base area. So since we already have the height in the equation, so we can say that this equation can be written in the form of this equation. So at this point we are done with what the question required us to do. So we can conclude that for A, since the left hand side and the right hand side of the equation are equal, then the equation is dimensionally correct. Thank you for watching. Remember to subscribe to our YouTube channel and ensure that you drop the comment in the comment section.